Okay, so let's go over a practice chord assignment here. It'll be like yours, just different numbers. All right, so length of AE is 5, DE is 3, BE is 7. Find the length of CE. Well, we know when two chords intersect each other within the circle that if I multiply the two pieces together of the chord, they equal the other two pieces of its other chord. So I have 5 times x is 5x, which you see right here, equals 7 times 3 is 21. And last step, divide by 5 on both sides and you get 21 fifths. Or if you like the decimal, 4.2. All right, number 2, AE is 15, CE is 12, DE is 9, and BE is 2x. So again, I multiplied 9 times 2x is 18x, 15 times 12 is 180, divided by 18 on both sides, and you get x equals 10. Now notice it didn't say solve for x, it says solve for the length of BE. BE is 2x, so I have to go 2 times 10, and I get 20 for my final answer. All right, let's come over here to 6. The length of SU is 26. So notice it's a perpendicular to that chord, which means it goes through the center of the circle. If I continued on through, it'd be a diameter. So that means it's also a perpendicular bisector. So it's 13 and 13. It says YW equals 26. So that means, again, it's the same length and it's perpendicular, so it's a bisector. And since those chords are the same length of 26, they both have to be equidistant from the center, which is why you see those two hash marks there showing that that length has to be equal to that length. And then you're given arc YX is 43. YX, we know since it's perpendicular, it also bisects the arc. So if that's 43, this has to be 43. And it has to be 43 here, and it has to be 43 here, because those chords were the same length. Now you can just fill in those numbers, or those answers right there, no problem. All right, number 7, length of PS is 20. Remember, that's a radius. PM is 16. Well, PW would be a radius as well, so it would be 16, so that makes that a 4 right there. Okay, find AT. AT is the entire length. Okay, well, since it's a perpendicular, we know it's a bisector, so both sides are the same right there. And so now I have Pythagorean theorem, x squared plus 16 squared equals 20 squared. Or I can look at that as a 3, 4, 5 multiplied by 4. 3, 4, 5 Pythagorean triple. If you know your Pythagorean triples, multiply by 4, so that makes x equal to 12. That's what we got here when we do the Pythagorean theorem. And then 12 and 12, because the other side's over here, is 12. 12 plus 12 is 24, so the length of AT is 24. All right, number 3. If the length of PR equals RQ, so that means those two chords are of equal value, that means and that their arcs are of equal value. They're also equidistant from the center. But that's not what we need to know. But we know their arcs are the same, so that's why you see x here and x here. And it says arc PQ is 116, so I put the 116 there. Well, now I have the full circle. So now 2x plus 116 has to equal 360. Subtract the 116 across, you get 244. Divide by 2, and you get 122 for x. And it wants arc RQ, which is x, so 122 is my answer. Number 4, arc AB is 2x plus 24. Arc DC is 8x minus 60. Angle DEC is 104, so I got vertical angles there. Solve for x. Well, we know that the interior angle here of this 104 is the average of their two intercepted arcs. So I add those two together and divide by 2, or I could add those together and multiply by the 104 by 2, which is what I did here. So again, these are just formulas you need to memorize. Okay, so 2 times 104 is 208, plus the 36 across is 244, and last set divided by 10, and you get 24.4, and that's what it asked solve for. Make sure you go back and read the question. So I'm done right there. Number 8, explain why AB is or is not a diameter. Remember, in order to be a diameter, this has to be 90 degrees. Is it 90 degrees? No, it's not. It's 91 degrees over here and 89 here, so it's not. It must be 90 degrees as explained right here. Explain why AB is horizontal diameter. Arc CB is 50 and DB is 51. Well, remember the arcs would have to be congruent, and they are not. Okay. Therefore, angle AGB is not 90 degrees, and therefore it's not a diameter. Number 10. The length of AM is 3x minus 1. Since this is a perpendicular, we know it's a perpendicular bisector. It goes to the center, and so that makes the other one the same length. So it says MT is x plus 14. Well, those are congruent, so I can set them equal to each other because that is a perpendicular bisector going through the center. So I set them equal to each other right here. Subtract the x across, add the 1 across, 2x equals 15, divided by 2, and you get 7.5, or 15 halves, you like the fraction. Number 11, AD is 29, that's the length of that segment. BC is 29, so we know that the arcs are the same, whatever they happen to be right here. We also know that they're equidistant from the center, if we need to know that, but we don't. And it's telling me, I added in here, AD is parallel to BC, which then means the inside arcs have to be the same. So this is arc AD is 144. So there has to be 144. Arc DC is 7x minus 5. So there has to be 7x minus 5. Now I have the full circle, so I add them all together, combine like terms, sum equal to 360. Okay, I do that, I get 14x equals 82, divided by 14, and you can divide each by 2, just simplify down to 41/7 is what x is. Exact answer. Notice you always do the exact answer unless it tells you to round. Here it tells you to the nearest tenth, so I'm going to do to the nearest tenth. Number 11 did not say, so I must leave it as the exact answer, 41/7. Okay, so RJ is x, it says. JD is 7. Well, JD is the radius. So if this piece up here is x, then this other piece up here has to be 7 minus x to add to 7 for the total length of the radius, which we know we got 7 from this side. Okay, so now I know those pieces. Okay, and I got 2 chords that intersect. So again, the individual pieces, 9 times 4, 36 equals 7 plus x times 7 minus x, that piece. I multiply that together. You see that should recognize that as a difference of perfect squares. So I multiply the first two together, 49, multiply the last two together to get negative x squared. Okay, so I add the x squared across to move and make it positive. Subtract the 36 across, I get x squared equals 13. And it would have 2 answers since the degree is 2, but since we're talking about a real life problem, you can't have a negative answer. So it's just the positive answer. It's just x equals the square root of 13. That's the exact answer, but go back and read the directions. It did not ask for the exact answer. It asked for the nearest tenth. So now I put that on my calculator, round to the nearest tenth, and I get 3.6. Okay, backside now. We have EF is 23, and HG is 23. So those chords are of equal length. They're equidistant from the center. I have that marked. Okay. QL is 8x minus 4. QK is 5x minus plus 8. They have to be congruent because they're equal chords. So the distance is center is the same. So I set those equal to each other, which is what I have up here. Set them equal to each other. Subtract the 5x across, you get 3x. Add the 4 across, you get 12. And x equals 4. Pre-algebra. Right there. Okay, 18. OR equals RS. Well, since these distances are the same, that means the chord lengths have to be the same. Okay. And it's a perpendicular bisector. So that's why you see hash marks on each side there. It says RS equals 3. AS equals 12. Find DC, the total length. Well, since this is 12 here, this is 12, and these chords have to be the same length since they're equidistant from the center, so DC has to be 24. 13, find the radius given. Okay, we have HG is 90. Since it's a perpendicular here, it has a perpendicular bisector, so 45 and 45. Okay. QL is 24. Okay. I've had to add on EF is also 90, so that means these chords are equal length, so they have to be equidistant from the center. So if QL is 24, then QK also has to be 24. Okay. Find the radius. So this radius is this one right here. I have the answer for it, but you get 45 and a 24. I can see I could divide each by 3, and I have an 8, 15, 17 Pythagorean triple. Otherwise, I use Pythagorean theorem to get the 51. I can see I divide each 45 and 24 by 3, and I get 8 and 15, so that means the hypotenuse has to be 17 times 3, which is 51. Using my brain, because I know my Pythagorean triples, and I can divide by basic numbers and multiply by basic numbers. Otherwise, you use Pythagorean theorem. All right, 19, OR equals RS, so that means, and they both equal 4, so since they're equidistant from the center, the chords have to be the same length. It goes to the center, so it's a perpendicular bisector to the chord. If I wanted to put that in there, I could put that in there, just like I could put that in there, and that equals there as well. Okay, it says DC is 12x minus 8, and AS is 3x plus 6. Well, AS is only half of it. So since the other half is also, that's why you see the times 2 here. And DC is the whole length over there. So now I set those equal each other. When I double the 3x plus 6, I get 6x plus 12. Subtract the 6x across, I get 6x. Add the 8 across, I get 20. Divide by 6 on both sides, you get 26. Divide by 2 on each side of that to reduce that fraction, or simplify that fraction, and I'm down to 10/3. Notice it doesn't say give me a decimal answer. It doesn't say give me a rounded answer. It says solve for x. That means the exact answer. Now, if you want to write that as a decimal, it's 3.3. Repeating bar. You cannot forget your repeating bar. If you write 3.3, you lose a point because you rounded. It does not say to round. It says solve for it. It means the exact answer. Okay, 14 here now. PR equals RQ. So those are the chords. They're equal length. So that means their arcs are equal length. If arc PR is 96, find the angle of PRQ. I want you to find that angle. Well, I know this other arc has to be 96. That's 2 parts of the whole of the 360. So I have 96 plus 96. I want to call that x. So that'd be 192 plus x equaled 360. Subtract 360 across, and you get x equals 168. Now, remember, that's the intercepted arc. The angle itself is half of that. So what's 168 divided by 2? 84 degrees. Inscribed angle. All right, number 20. Arc BC is 86. Arc AD is 73. Find the measuring angle AED. Right there, which is the same as this one. So we know it's the average of the two. So 73 plus 86 divided by 2, right over here, equals 79.5. All right, number 15. Arc PR and arc RQ are equal. So that means these chords here are of equal length as well. Those two have to be the same length, just so you know. Since the arc measures are the same length, if arc PQ is 136, okay, find the measuring angle PQR, which is this one. Well, if that's 136, we know this is x and this is x, right here and here, because they're the same. So 136 plus 2x equals 360. Solve for x, you get x equals 112 degrees. Okay, so I have 112 there. says it wants the measuring angle PQR. Wants this. Isn't that half of that arc? And so what is half of 112? 56 degrees. There's your answer. Okay, 21. Arc AB is 150. Arc DC is 114. Find the measuring angle BEC. BEC is this one right there. But I can't just go right to that, but I can find DEC and then just use linear pair theorem from there. Okay, so again, how do I get DEC? That's the average of the two arcs like we just did earlier. So 150 plus 14, okay, is 264 divided by 2 is 132. That's why I see 132 right there. Now that forms a linear pair with my blue arc B angle BEC. So 180 minus 132 is 48 degrees, and that's what it wanted. Don't forget to make sure you find the right angle. Common answer would be to pick 132. If this is multiple choice than DCAS, they would probably have 132 as angle as letter A. Make sure you find the correct angle. All right, number 16. Find MT, which you call X right there, given the following. Segment MN is tangent, so it means it's 90 degrees. Circle P at point K. PS is 8. That's a radius. So PK also has to be 8. PT also has to be 8. MK is 15. Well, I should know I have an 8, 15 Pythagorean, 8, 15, 17 Pythagorean triple. So this whole length has to be 17. So 8 plus what is 17? 9. That's why I have X equals 9 there. And there's my answer. Pythagorean, or else you have to do Pythagorean theorem, which is a lot more complicated when I'm doing 15 squared plus 8 squared equals 8 plus X 20 squared. Now you have a lot more algebra involved. You can do that. It'll get you the answer of 9. All right, 22. Okay, angle DEC is 62. That's right here. Arc AD is 123 right there. Find the measure of arc BC. That's my X right here. Okay. Well, so I know that if this DEC is 62, then right there has to be 118. It's a linear pair. Well, if I double that 118, which is 236, right here, that has to equal that arc plus that arc, 123 plus X. So now I just subtract 123 across, and I get X equals 113 degrees. Okay? Again, you got to memorize your formulas. 17, chord AB is parallel to chord CD. And write my parallel symbols on there. That means these inside arcs have to be the exact same. It says if arc CD is 99 and arc BD is 47, well, it puts the other one at 47. Find the arc of AB. Okay, so I have 3 of the 4. I'll be left with an X right there. So 47 plus 47 is 94, plus the 99, plus the X equals 360. Solve it now for X, you get 167 degrees. Okay, last one. Chord AB is parallel to chord DC again. Okay, remember DC is also called the diameter, the longest chord of the circle. If AB is 72, find arc AD. Well, we know that since these are parallel, these inside ones have to be congruent, so we can call them X and X. We'll put the X there and the X there. And we see that it's a diameter, so the top half adds to 180 degrees total. So I have X plus 72 equals 180, 2X equals 108 divided by 2, and you get X equals 54. So arc AD is 54. Okay, that will do it. Just over 19 minutes.